Yeah. So welcome to this afternoon's session. Today we'll be doing an introduction to decarbonisation. You want to just launch the... Yeah, okay. Actually get the... Brilliant. Won't be telling everybody about my spelling mistakes. I'm Howard Neville. I'm the Vice Chair of ASHRAE Ireland, and I'm the Chair of the Technology Transfer Committee. So today we've got a fantastic afternoon for you. We'll be talking to Drew Crawley, who will be giving our presentation. If I just move on, I can go through what our agenda is. So we'll hear from Dr. John Ryan, who introduces us here to the facility here in Ermid, and then Drew will be talking for us a short discussion at the end. Then hopefully get you on the road before 6 o'clock, and let you get home. Unless you're already home. So questions that we'll take questions and after questions at the end of the session. But if there's something urgent, if you want to throw it into the chat function, and we can address it. If you're having difficulty, if you want to email secretary@ashraeireland.org, Karen is online and will deal with your questions. The session will be recorded, and we'll put it up on our website afterwards. And I think we will have some handouts, and we'll put those onto the website as well. That'll be in our members section. If you want to continue the conversation, you can go on. I'm going to call it X at ASHRAE_Ireland.com. Or sorry, _Ireland. On LinkedIn, it's ASHRAE-Ireland, and YouTube is @ASHRAE, and that's _Ireland. I think is what it is, but I'm sure if you type it in there, you'll find us. And there's a bunch of previous sessions that we have in there. We have some upcoming events to let you know about. We have a YEA welcoming with President Dennis Knight. That's in UCD on the 6th. We'll be having our annual general meeting on the 27th. And we will be having it's just been confirmed that Marwa, I forgot Marwa's second name, sorry. Marwa, what's Marwa's second name? I don't know. You don't remember either, okay, I don't feel bad. So my apologies, but Marwa will be speaking. We'll be having and then in Phoenix in July, we'll be having the summer conference, and Connor, Marie will be speaking at that, as will Alex Brandt, I think, is also speaking. So that'll be interesting if you're stateside. We have just launched our mentorship program. Alex will be talking more about that on the 6th, and we have Soren here today, who's actually my mentor and joining in. So far going brilliantly. If you're interested in our other upcoming events, if you want to go onto our website, and please. Do send us an email, or you can let us know what you want to hear about in 2025. One thing I will ask you to do is go to ASHRAE membership, or go to the ASHRAE Ireland and then join our mailing list. So if you're not, we don't drive you mad with daily stuff. It's just when there's things to know about, and we'll keep you up on when the next events are happening. You can get involved. You can join if you're not. Join ASHRAE. Do please. You can members can join as a committee role. Has been very, very rewarding for myself. I can say that. And as organisations, we will be reaching out to get on sponsorship. That's what makes these things possible and keeps them free for everybody. Okay, I'll hand the room over to Dr. John, who's going to just welcome us here to committee. So Dr. John Ryan is the CEO of Ermid, and he's director of AI. Is it AI?
The IR Group.
IR Group, excuse me, sorry. And has hosts here today very kindly. So hand over to yourself.
Sorry. Just welcome everybody online to Ermid virtually. You're quite welcome to come and visit the facilities anytime from a physical point of view. And what we do here that's relevant from an ASHRAE point of view, I guess, is we conduct independent testing and validation of lots of different types of technologies that impact the indoor environment in which we kind of all live, work and breathe. And we do that in lots of different kind of functions, and we've loads of different kind of kit, and we have on-site microbiological labs. And we're also heavily involved in various standards committees, both at the ASHRAE level and the environmental health committees, and looking at the changes to the standards and the impact for technology in the market. So most of our customers are the manufacturers or users of equipment that relate to how HVAC systems work, or maybe technologies to improve the air quality within those systems. And then we have on-site facilities for doing quirky things like challenging those with microbes like viruses or bacteria or molds or allergens or lots of other interesting things. So we're quite happy to facilitate and to support ASHRAE Ireland. We're great believers, I guess, in bringing people together and learning. It's part of our kind of mantra. In our wider group, we have an academy that teaches people around kind of the medical impact of poor indoor air quality. And we're delighted to partner with people from as diverse as architects and designers, to HVAC engineers, and to medical professionals. So with that, I'd like to welcome Drew. We've had a very quick whistle stop tour to one of our chambers and see what we do a little bit here. So hopefully that kind of stimulates some thought for your discussion this afternoon. Thank you.
Thank you. I just welcome Drew. I think the hardest part of organising this was getting Drew's sorry, just the bottom there, page there. I want to click on slide 5 there for 1 second, please. No, stop. Okay, no, that's okay. Yeah, I had to get down to one slide, and that was the hardest thing. Oh, there we go. Thank you. There we go. So Drew is a fellow and director of Bentley, all the way from Washington DC in the USA, the epicenter of the world right now, I think. So Drew has had over 45 years of experience, and in that time he has worked with the US DOE, is it? I'm saying that right? Yeah, US DOE, where he was involved with I'm going to read out there, Developing Commercial Buildings Initiative. He has a PhD from Strathclyde, from this side of the pond. I know there'll be probably a few people here online who are alumni of Strathclyde. And then within ASHRAE, he has been Director at Large of I'm not saying that right, the ASHRAE board, and multiple technical committees. You haven't listed out, I have to take them off. There was just so many, there was just too many to mention. Of course, distinguished recipient of the Distinguished Services Award for that reason. So I'll hand over to Drew now. Thank you, Drew.
Sure. Yeah.
Well, thank you very much for the invitation. It's always good to be in Dublin. I was here about 18 months ago. One of the groups I'm involved with, ABIPSA, Building Performance Simulation, had our board meeting here. So we partly because most of our memberships here in Europe. But so what you're getting is kind of a shortened version of a 2.5-hour talk I give for ASHRAE Learning Institute. So that's this is kind of a truncated version of that, but the core content is still here. Much of the material came from other places, other people, multiple past presidents, Kent Peterson, Ginger Scoggins, Don Culver, Tom Phoenix, all past presidents of ASHRAE, and others who were together with me on the task force for building decarbonization, and that's how I was able to at least start the outline of what's here. So we're going to talk a little bit about building energy and carbon, terminology, carbon in buildings, building decarbonization, and what ASHRAE is doing for decarbonization. I will say that I'm going to cover some of it very briefly, and I will be sharing the presentation so the chapter can post it, because there are like 10 pages of web links at the end for various resources to make it easier. We won't go through that. Excuse me. Talking about allergies. So we are seeing, in late 2023, the global population changed to 8 billion people on the planet. We're expected to add another 2 billion in the next 30 years or so. So that's a big move forward for that. And that means that we have to deal with a 26% increase in people, housing them, having places for them to work. And that means we're going to have to create more space. And estimated by 2060, we're going to need 230 billion square meters of space, which is constructing New York City every month. Now, it's not going to happen in the term the UN uses, the global north, the blue part here. It's all in the global south. And you see this is a population growth. North America grew a little bit. That's only like 1% or so. Europe is actually down a bit last year. Asia is still growing. Africa, of course, being the highest growth area. And that's where a lot of the largest growth. China is shrinking a bit at this point, but India is continuing to expand. Indonesia, Nigeria, and a few other African countries are going to be larger than any other countries out there in terms of population. We have, under the Paris Agreement, countries committed to trying to reach a 2 degrees C, but it was changed to 1.5 as far as the 2018 IPCC recommendation. But that's already a challenge. I'm not going to talk about climate change here, but last year was already at 1.54 degree change globally. So we're already exceeding that, and we were supposed to do this, not reach this until 2100. The other thing I'd like to talk about is our energy, because energy and carbon are somewhat interchangeable, particularly buildings. But globally, buildings are responsible for about 30% of the energy and 37% of carbon. And a lot of that's driven by electricity with other use. The range is there, the third and fourth bars, China and Hong Kong, where China only about 20% for buildings. But when I started putting these together 20 some years ago, that was only 10%. So they've doubled the amount of floor, or at least the energy consumption in the buildings. Hong Kong, on the other side, is 65% buildings and only a little bit for industry. So industry energy use is driving their economy in China, and they have a lot of coal use as well. And you see it kind of Europe generally just a bit under 40% for buildings, and varies by countries around there. Ireland, you see how the energy here is the energy consumption, oil the predominant source. Coal topped out probably 20 years ago, it looks like, and natural gas is taking a large role. But look at how much wind and solar have expanded over the last few years, and you can see that just driving around the countryside, seeing all the new renewables in place. And that's not an unusual change that we're looking at. In the US, about 40% for our buildings, half residential, half commercial. And I only show this just because I want to make the point that our buildings are quite different than they were 20 years ago in terms of what we were doing. Yes, we have traditional heating, water heating, cooling, and appliances and cooking. Computers are showing up in US buildings as a percentage, but then there's this whole category of other uses. And what that means is devices like this that draw a little bit of power are now accounting for a full quarter of energy use in the US. I have 25-year-old twins, and our son is living with us again after university. And I wonder why my Wi-Fi is slow. I go on the router and there's 17 devices connected, and probably 16 of them are his. He's got everything on it. So that's what's driving that today. So we need to keep in mind that it's not just the traditional things we worry about, building fabric and the systems. It's got to be everything within the building as well. As far as commercial buildings, and this is across everything, but if it were Supermarket, grocery store, refrigeration would be 50% of energy use. Cooling and lighting kind of secondary in what's there. Office building, yes, heating, cooling, lighting, ventilation. But the interesting thing to me across the sector, office equipment and computing was now 13%. And a lot of that's driven by growth in data centers and other computing uses there. Again, there's another large other use percentage that does include elevators and other lifts and such. The computing, I think, is going to continue rising for a while. There's such demand for AI computing that we're seeing data centers, particularly where I live in Washington, D.C., Northern Virginia is kind of an epicenter of that because 70% of the world's internet traffic goes through there. And which is surprising, but when all the fiber optic cables were being put in place in the 90s, that was already a big hub for that. So that's kind of not surprising. So we are seeing kind of that drive for that. If we look at carbon emissions, buildings are responsible for about 37%. And if you look at breaking that out, 10% of that 37 is for new construction. That's the embodied energy and the energy to construct, with residential taking about half of the remainder and non-residential a little less. So why do we care? If we're going to actually decarbonize and be able to work to affect climate repair, I will say, we're going to have to limit climate change to less than 2%, which is increasingly very difficult given where we are today. And that means decarbonization of our energy systems by 2070. In some cases, it needs to be earlier. A lot of nation states, and I think companies, cities and companies are really taking the lead here today to replacing current systems. There are a number of places that are saying they're going to be net zero by 2030. And so they are looking to transform their energy supply. And a combination of getting away from fossil fuels and moving toward renewable electricity is really a key. This is a chart you may have seen, just shows the increasing level of carbon dioxide in Mauna Loa, which is a dormant volcano in Hawaii, and this is above the normal part of the atmosphere, so it's not really affected by anything down below. And so they've been able to record that. It is now above 450. This just ends in 2022, but last year, 2024, was over 450 parts per million. So it's, and the used to be that the slogan was 350, and now we're already 100 more, 30% more than that. It's kind of a compounding effect. Most of the carbon that we put in the atmosphere has been there in the last 40 years. Initially, it was OECD, which is primarily Europe and the US, and back early in the century, but they're still contributing almost 40% of that. But energies in transition, Asia, Latin America, Asia particularly, China's growth in energy has been just phenomenal the last several decades. So why? Well, climate change is probably going to affect every one of us. It's going to be the biggest challenge we as a society have faced in trying to do it. It affects everybody in different ways, but it is something that we're going to have to deal with if we're going to be able to survive. There are places that are going to be too hot to live if trends continue. Buildings are already responsible for over a third of the carbon contribution, and the building stock is supposed to double by 2060. So we're going to be even exacerbated that. If we're not careful and design our buildings to be energy efficient to begin with, they can lock in those energy losses, high emissions for decades. Even with change out of mechanical equipment and efficiency over time, it's still the inefficiency inherent in the building, it will be there. So UN Environment Program says we got to cut by about 50%. That's about 6% per year by 2030. And when they wrote this, which was a couple years ago, that was 6% per year. Well, we're already not getting any savings. The the drop 6% was about equal to what happened during the COVID pandemic when everybody stayed home. But we've already come back and passed that globally today. This is a commitment for meeting the Paris Agreement, the 1.5 degree decarbonizing, particularly, and there are a few countries that have achieved it or are about to. Uruguay 2030, Finland 2035, and a few smaller countries that had huge hydro resources to begin with. But the bulk of them, the blue bar is 2050, and that's what people are saying they're going to be able to achieve. Of course, the U.S. has withdrawn or will withdraw from the agreement, on its backpedaling on just about everything. But I think the world is already moving forward, and one of the things, my personal opinion, the current administration doesn't understand. They think that coal was punished for being coal and being dirty. And the reality is that natural gas was cheaper and renewables are now cheaper than anything as a new source for electricity. And that's been true for a while. I lived in California in the 90s. And at that point, the cheapest source for the electric utility for new power were wind turbines. And that, 30 years ago, that was already true. So it's not that coal is dirty so much as it was a cost reasoning for that. And so I think we're going to see it continue in the US despite the lack of interest from the administration. So I'm just going to flash through this just to give you idea of terms we're going to talk about: carbon dioxide, global warming potential, greenhouse gases. These are all definitions from the IPCC. Carbon dioxide equivalent emissions, or CO2e, that's really the key there. It's basically taking the global warming potential of each of the constituent gases that we're emitting and then multiplying them, multiplied by the global warming potential by the mass that's there, and then look at that over a 100-year horizon. So if I'm talking about carbon, I'm mostly talking about the carbon equivalent for everything here. So other things, operational carbon, the emissions from operating something, the building or the industry plant or whatever. Embodied is the carbon that was associated with creating the products, the materials, construction itself that are creating our buildings. Direct, we're talking about fossil fuel, direct combustion on site. Indirect will be, well, the power plant has to use some sort of fuel if it may be a fossil fuel. So that's the indirect part of that. And what you used to hear prior administration was electrify everything. Electrification is really an important thing, and heat pumps were being pushed in a big way. I know in Europe they were as well. Germany was going crazy with heat pumps, and I think will continue. The problem is that if we electrified everything in the US, the grid would fail. We need twice as much power as we have now. So we don't have, one of the things that has to be done with electrification is efficiency. And if we don't do that, we're going to be paying for a lot of new power plants. Other things we'll talk about: life cycle assessment, environmental product declaration, carbon capture, site carbon sequestration, like trees, building performance standards, other things that are happening that are pushing in different ways. So when I talk to most ASHRAE groups, I kind of feel like I'm preaching to somebody who already knows what I'm talking about. So I'm sorry if I'm kind of doing that, but this is from a ISO standard or a European norm, looking at the various elements, and you get embodied in the product and the construction, even in the maintenance and use. You'll replace materials and systems over its lifetime, and then dealing with it. So it looks like a lot of the embodied carbon is dominating. For most of our buildings, operational carbon still outweighs the embodied carbon in there. As the buildings become more and more efficient toward net zero, then we'll get there. So here's kind of an example, kind of typical building, 20-year life, embodied carbon, 400 kilograms per square meter over that 20-year life, or a very efficient building, only 20. And the initial embodied carbon you see there estimated at, I don't even have the number up there, okay, but at whatever number, 4,000. And what it shows is that as the buildings become more efficient, much more efficient, then embodied carbon is going to take over. I think this gives us some time to work on that. Two of our building materials, infrastructure in general, that are very energy and carbon intensive are, steel and concrete. And there already moves afoot to do that. I know car manufacturers, I can't remember which German one it was, but they're already talking about blue steel or green steel, where they're producing the steel to make the car with renewable energy. So they're not contributing to that. So we have some time to try to make that initial embodied carbon, because once you use it, it's already there. There's no reason to try to replace it. The new should be. So on-site combustion of fuels, off-site from electricity or during the production of that, and then the emissions related to it. Another big one we may not think about is refrigerant leakage. Buildings are actually pretty good about not leaking. Our transport, the lorries and everything driving around out there leak quite a bit. I'll talk about that a little later. So what does that mean? It means if we're the decarbonization in the building, we've got to reduce the man-made carbon emissions entirely. That is the ultimate goal here. So it means moving away from fossil fuels, energy efficiency, and that's got to be clear there, switching to cleaner sources and low carbon electricity where possible. The grid will continue to get better. They have been for many years. Okay. So this is from the International Energy Agency. This is their kind of roadmap for how they could get to zero in buildings. So 2020, we're starting with there. By 2050, we've doubled the amount of energy area. So the mitigation, energy efficiency, electrification, some other behavior and other elements mean that we can reduce by 98%. That's close to zero. So that is a possibility. So a combination of efficiency and electrification are really key for that. If you look at it kind of a little more, what's causing that additional activity, we're increasing lighting, cooling, and appliances, and electrification is going to raise the amount of energy needed a bit more just because of the inefficiencies of the grid. So efficiency's got to account for about 40% of that. So we can't just say electrify everything. That doesn't solve the issue. Lots of things that go on, reuse that we can do that. Reuse existing buildings as much as possible. If you've got the structure in place, you can cut the embodied energy probably up to half. We're optimizing orientation, geometry, passive efficiency. I feel like I'm talking 1980s, 90s, things that we already talked about, but that is all still part of it. Minimize embodied carbon, looking at materials, electrifying, GWP, refrigerants, low, and then finally getting to the point you've done all the on-site you can, so you purchase off-site or do real-time carbon usage. And there are some technologies in use today. So the problem is our buildings are often unique. You may build two buildings that are identical in floor plan, but they will be used differently. And everything from our homes up to the large industrial plant, everything is different. And so there's no one catch-all solution, residential, commercial, industrial. 80% of the buildings that'll be here in 2050 are already here. We'll see some growth throughout the north, but 60% of the buildings in the global south are there. So that means we have to retrofit the existing buildings to be able to meet any of these targets. Generation, electric generation fuel mix is quite different depending on time of day and location and capability. Is changing all the time. Developed economies such as Europe, North America, probably can afford to pay for this to decarbonize their economies, but a lot of the emerging economies, developing economies probably don't have the resources to be able to do this. So net zero, we have net zero carbon operational, meaning no fossil fuels are being used. The electricity has been energy use is either on-site renewables or the grid is clean. That's one possible way to do that. Net zero embodied carbon, that's taking everything we put in the building to construct it is a product that's zero carbon was used in its production. Whole life carbon means the combination of both of those, where we are, it's all the greenhouse gases associated with construction and in the embodied and the operational, all are net zero or offset. And net zero upfront is minimizing all of that, but then working to do additional offsets to make sure that the building starts at zero to begin. A little different from that whole life, but there. The other thing is we have a number of standards, both energy and some carbon standards now in place, but many of them don't cover everything. The metrics, a lot for ASHRAE standard 90.1 for many years was the kind of the de facto energy standard, but it's now transitioning from an energy basis to a carbon-based standard, and that's what it's going to take to help we start thinking about kind of the end result, not just how the energy is done. Many standards globally are more prescriptive instead of performance. Performance gives you a lot more flexibility. And then it goes, where are you measuring? What's the boundary for that? Is it just the building site, or is it back all the way to the power plants, and how can we look at that? Also then, is it carbon emissions? Is it other metrics? What are we starting with? We also, particularly in the building services area, need better labeling and reporting on carbon emissions. We don't have good ones today. There's some hope for that, I think. So this is from a UNEP report showing the purple areas have some sort of standards. You see, even in the US, we don't have statewide standards on many of those states in the middle. Now, large cities in there probably do, but for most of the state, there's just nothing that's requiring any energy efficiency. You see some hope in South America, Europe, Asia, at least North Asia is pretty good. India has one. It's not terribly well enforced at this point, but you see kind of that blank slate for Africa, and that's where a lot of the construction's coming. The other thing, metrics. What are we specifically talking about? I can talk about carbon dioxide equivalent, but where are we measuring it? Is it energy or carbon, embodied or operational? And then which of the carbon metrics do you want to use? The average, hourly, historical, forward-looking, cost-based, and different organizations are using all. I mean, some people talk about a 20-year horizon, some people talk about 100, and that makes a big difference for there. I believe the ASHRAE board has said to use 20-year now. I may be wrong on that. Offsets, CIBSE, US EPA used to, World Resource Institute and ASHRAE's new standard 2228 all allow offsets against that operational carbon for that. Do we have a common measurement? ASHRAE 90.1 is pretty much regulating everything except the interiors. Kitchens are included, ventilation, lots of different sources there, but is it everything, including all the plug loads that I showed you, can be a large part of both. And then embodied carbon and doing life cycle analysis, do we have the data? And Europe's got decent data sets for LCA, but the US is kind of spotty. And then in other places, there's just no data available for looking at what the carbon impact of various products and systems are. So I mentioned refrigerant leakage. This is way out of date, 2000. That's the latest I could find. I talked to a friend of mine who works in that area, and he said that's the only data they've got. But if you look at domestic refrigeration, up to about 0.5% a year loss, not bad. But we start looking at medium and large commercial, transport, industrial, we're seeing up to 50% loss of refrigerant a year. And that's a huge amount of global warming that's caused just by them. Our chillers are AC, not bad. Chillers about 15%, heat pumps down in the 5% range. So not contributing too much, but there's still more that we could do because they are particularly high global warming potential. Other things, timing, depending on when you use electricity or any fuel, what are the generation source and the emissions? When do they occur? Would it be better if you use energy at different times? Energy storage, could we offset some of that by storing energy, both thermal and or electrical, which we're beginning to see there. Seeing more of that in the utility scale. I've seen several 5 megawatt systems that are gone up in Australia, and they're using them not only as backup but as real time peaking to try to reduce the cost of peak electricity because they can store the renewables at night. Keep talking about heat pumps. Heat pumps don't work so well once you get below about -8, 9. They work okay, but then you're getting down to electric resistance, and so your COP of 1. But there's a lot of work going on that right now, so I expect we're going to see some sea changes in cold climate heat pumps. We don't know what's going on with the grid. We don't have a lot of good information. ASHRAE has written a guide about integrating with the grid and how to go about getting that information, but it's got to be more than just load controllers. My mother-in-law had a load controller in her house that the utility would send a signal, the heat pump would stay off at the peak times in the afternoon when it was hottest for an hour or two. So her house would get a little warmer in the summer, but not too much. That's not what we're talking about. We're talking about more real-time information from the grid, so that look ahead, they say, we've got a peak coming up, can you help? And that's more what we're talking about. Our maintenance and operation, our buildings get more and more complicated every day. And did we do a good job getting the building running, commissioning, getting everything operating like the design professionals wanted to? And is it old enough we need to go back and do it again? And probably yes, is the answer there. The experience I had when I was at DOE was that commissioning was done poorly, if at all. We had a building that they had the researchers go in after the commissioning was done, and controls were wired backwards, so something was on when it should have been off. The window glazing was supposed to be 2 different types, and they put the wrong windows in the wrong place. So there are all sorts of things that happen during construction that can negate the effect of a good design. Transportation, we're dealing with EVs, energy on site. I see EV chargers around this office park. How is that contributing to energy use? Grid security. And security is kind of a real issue. A lot of what we're talking about today, just because who has access to information and when should they have access is important. Are the guides, standards, and the codes actually having an impact for the local people? Are there ways you teach people how to go about doing a better building in a guide? Standard limits what you do, and then the codes is the legal limit. But is that all cooperating? Value and economics, what is the cost of carbon? What's the cost of energy? And how is that working together? Is it are we seeing the benefit of reducing our carbon in particular buildings? I see estimates on financial investments on the order of $3 to $4 trillion a year that need to be invested to make our buildings better, just our buildings for that. And that's a large amount of money that we have to be put forward. And is there any return for that? And do we have the people that can do it today? It's a workforce. Are we training people the right way to be able to not only manage these more complex buildings, but to build them as well? This is another one from the International Energy Agency. Efficiency, electrification, grid friendly, and zero carbon energy, all kind of the key themes that they have. But we need the standards which are driving toward net zero, building performance standards. I'll talk a little bit more about that. The technical tools for design and retrofit professionals to do that, and the training to bring up a new generation that are able to handle this. Skip one. This is an example of a building performance standard. Essentially, what it means is that this is Washington, D.C. They have decided that beginning next year, buildings have to disclose their energy use, and they have to be on a track to reduce it to zero. Either net zero, they're buying offsets, or other ways. So this is showing, starting off with buildings over 5,000 square meters and DC owned buildings of 1,000, and then increasing to 2,500, and then on to everything over 1,000 square meters. So that's a big step forward for that. And this is an example. This is Boston, and they've actually set kilograms of CO2 equivalent per floor area for each year by all the building types. So they're already beginning to look at that, and you see that by 2050, everything goes to zero. I don't know how it's going in Boston. New York City has the same thing, and the targets are beginning to hit the end of this year. And so there's supposed to be like a 10% reduction in energy use or carbon use in every building in New York City, which will be very interesting to watch. So that is so the building performance standards are kind of pushing that efficiency, that carbon reduction as top down. Renewables. Renewables play a big role both at the building, but also at the grid. A tenth of global electricity, I think it's up over 15% last year. I don't have a new update on this, but it's the fourth largest source behind coal, gas, and hydro. And I think that's changed, that in some cases I've seen it surpass coal recently. But if we look at it, North America, US was about 13%. That's pushing 20% now. But other places, not so much. Canada, a little lagging there, but they have a huge resource of hydropower in much of Canada. South America, Chile at 21%. Really good, but Uruguay is getting over 46% of this power. And there's some days that it's totally renewable energy. Brazil looks like it's kind of behind at 13%, but over 40% of their electricity is already hydro-based. And it's only the last 30 years that have really driven them to build new power plants that are other. Look at Africa, not much. I mean, Mauritania and Morocco in 13, 14%. Kenya doing well at 17, but much of the rest of the continent is not doing anything. And if you look at Nigeria, which is the largest economy in Africa, it's an oil economy, so they're not really that interested in renewables right now. They have cheap resources. If you look at Asia, China at 11, China is aggressively building solar and wind where they can. India is coming up. I was in India in, I guess it was February, and driving along the road, you would just see these huge wind turbine blades just sitting there waiting to be transported at night because they block every lane of the highway. But so they're really pushing for that. So Asia's got a bit of work to do for that. Australia, and I didn't point it out, but in the chart that showed the 2050 goal, Australia said they weren't going to be able to meet that till 2100, and yet they're already at 21% renewables for that. So the problem is they have a lot of coal and it's cheap, and they're shipping it to China primarily at this point. And of course, Europe doing quite well. 30s, Denmark up at 51%. There are a lot of days when Denmark, kind of in the spring and fall months, is totally renewable power for the grid. UK just shut down their last coal plant last year, so it's increasing as well. Finland, I think, is going to be an early growth. The renewables not so much, as they put a huge new nuclear plant online, and nuclear, except for the embodied part of the plant, the production part is pretty much zero carbon, so that it is still something that can be used for that. Other things we can offset, we can put the carbon in the ground or in the sea. Trees, of course, are a great source of doing that. Power station, we can capture, separate that. There's a lot of work going on to keep that clean. Pumping it into the ocean, and the ocean is the largest storage of carbon anyway. The problem is, as the ocean temperatures rise, as they've been doing the last few years, that means that they can store less carbon. Cold water stores carbon better. But put it into mining the coal beds, saline, or depleted oil and gas reserves as well. Get it underground. But if we look at our forests, 10,000 years ago, about 67% of the earth was covered in forests, and the other 42% was grasslands. But as people evolved, by 1700, we've cut some of the forest, but we've eaten into the grassland in a big way. Most of that's crops, and being able to do that. A little bit on grazing by 1700, but as the population explodes by 1950, that 6% for grazing, now 31%, and the crops 12%. And a lot of the crops are to feed that livestock. Grasslands down to 12% globally. Forests cut down, now we're lost about 10% for that. Urban's still quite small. By 2018, urban's now 1%, but the grazing is kind of at the same level. Grasslands recovering a bit, and crops is still growing. We've got 15%. What that means is we're eating into the forest. So if the forest is a resource for carbon sequestration, we need to use that. Unfortunately, we have places like Amazon and Brazil that everything's being cut somewhat illegally. So that's clearing one of the best resources for sequestration globally. Other things, we can store CO2 as a fuel. Forestry, we can use it in chemicals, often a lot, and a long list of other things, but frankly, those are the only two things we could do as a building. Working with concrete, reducing the carbon impact there, which is quite high, and also do it at the HVAC, the building services level, trying to capture it before it's released. So this is interesting. This company, they basically put something to capture the carbon before it goes up the boiler flue, and are storing it on site. And then once in a while, a truck comes by and takes the carbon off before they use it. So we're not releasing it into the atmosphere. I don't know what the cost on this. I can't expect that it's going to be cheap. Here's another one. This is literally, these fans are sitting up in the air, and they are through processes internally, they are capturing carbon out and pumping it into tanks. I don't know how well this is working. Another one, this was showing how it works, that putting the CO2 is absorbed into calcium carbonate, that then is with carbon captured, decomposes that, and then that's stored, and then that sends the calcium hydroxide back, so that it's kind of a continuous cycle for that. That's one way of having it happen. So how do we calculate all this? Whole building life cycle analysis is kind of the accepted method. It's a scientific method. There are ISO standards related to how to go about doing that. And it's now becoming mandatory in a number of different regulations and building certifications. But it looks at everything. It's not just global warming. It's acidification, eutrophication, ozone depletion, et cetera. The whole list of what is affecting the environment for that. So it's important to understand that we're not just looking for GWP out of this. Like with most things, the sooner you do an analysis, the better, more effective you're going to be. So planning, early design, you can have very effective reduction in carbon. By the time you're in construction, you're probably too late to do much. So that's a kind of a challenge for us. There are places, LEED, I think LEED version 5 has now come out and they're saying about the same amount. The zero carbon certification from the International Living Futures Institute has reducing embodied carbon of the foundation, structure, and enclosure. And that's kind of a theme there. That's the steel and the concrete primarily, and glass. And they're saying reduced by 10%, not terribly a lot. BREEAM from the UK, independent view of assessing the embodied carbon. A separate consultant does that. There are a lot of databases. I'll just say that here. Some of them are good for early carbon. Some of them, I think one of the good things is that the second one here, one-click LCA, is now getting embedded into our BIM products so that you have it direct from the BIM bill of materials to the carbon analysis. And it's allows you to do it from early design on through late. So there are a number of different ones. My company actually uses one-click LCA and Tally as both because they're primarily embodied carbon. We're not trying to, we have the capability separately to do other carbon, the operational carbon. But the EPDs that are put together in these databases are basically independently verified and tested document. So it has transparent information that can be vetted for that, giving the life cycle impacts of all the products
And an
in
assembly
control products. And it's accurate data kind of is the key for that. ISO standards, and then these EPDs are put together in various products. But without it, you can't really do it. Most MEP equipment sold in the US don't have an EPD. In Europe, I saw when I was doing some looking, a digital product passport was introduced last year. This was something posted there. So there's a part of the eco design for system product regulation information. So it's the same idea as an EPD, but it's European twist on that. But I think having that push from the EU is going to really move things forward. And I said, show me some images of EPDs, and it surprised me that there were quite a few. Now, very few of these are related to building services or buildings, but there are a lot. There's a lot of work going on out there, and so that is encouraging. There's asphalt. See if I can find anything. There's LEED, steel, other things. So you're going to see some products in there that are related. So what does it take? You define what you're trying to do, what goal you're trying to reach. You collect the inventory, all the materials, bill of materials primarily, energy and water use for the operational site operations. Then you do crank the environmental impact assessment, interpret the results and see what you can do. From that, it'll show you which are the biggest problem products for that. But that's the hardest part, is collecting that inventory because there's so little data out there available. That's why I think you'll see like LEED and BREEAM and the LFI, zero carbon, they all talk about structure and enclosure. They don't really talk about about what happens inside the building yet. As far as building equipment, of course, we have our fossil fuel powered things. Other things we can do, which are pretty important, lower GDP refrigerants, that can make a huge impact, particularly if you have a leaky system. Renewables such as clean fuels, green fuels, hydrogen, methane recovery using biofuels. Heat pumps, of course, possibility there. This was actually in the April ASHRAE journal. And so it kind of gives you a history of first, second, third, and we're now in fourth generation. HCFCs into production except for R123, and phase down of HFCs is already beginning. In the EU, F-gas regulation accelerated that HFC phase down with a complete phase out by this year. Next generation, these are where we're going to see ultra low global warming potential. So here's kind of a list. There's ammonia, water, air, carbon dioxide, propane, butane, isobutane, and a number of new mixes. And you see there's a combination of things. Their global warming potential on the far side, you see them quite low single digits. A lot of the ones we just phased out could be hundreds of equivalent in the global warming potential. And you see all the bits and pieces there, but one of the key things is they have to be safe. And ASHRAE has a standard 34, which deals with refrigerant safety. And an A1 means not flammable and people can be exposed to it for long periods of time. But ammonia is not in that category. It's not safe. Some of the fuels there, propane, butane, also limited amount of time exposure for that. So the ideal was to find something that's very low global warming potential and at the same time safe to be around. Heat pumps, and again, I feel silly talking about heat pumps, ASHRAE, but there's really good information there about it. And the interesting thing I learned about, which I didn't know, is that heat pumps are everywhere from our cars, which are using, particularly electric vehicles, are using heat pumps for being a very efficient way to heat and cool the cars. Because normally we either have a separate cooling system and we're using waste heat off the engine to heat. But in EV, we don't have that. So lots of sources scale up to industrial and also residential appliances happening today. So lots of boxes you'll see attached to buildings. One of the interesting ones is a heat pump water heater that will essentially acts like a heat pump and does heat your water. We bought one recently and it actually works pretty well and helps a lot. We can control, we can program it to be off when we're not around and so save a lot there. The other one that my wife we did buy one, was a heat pump dryer. There is no vent out the back that is dumping moist, warm air. The only thing that comes out of the heat pump is the water that's piped into where the washing machine dumps. We haven't gotten it to work yet, but we'll see. She keeps going, well, I don't know, we may have to buy a new one. Hope not. Chapter 9 of the 2024 handbook has a great discussion of heat pumps, and this table is just part of it. So it gives air, example of medium of air, the examples of it, heat source, heat sink, relative to mean temperature, cost, common practice. So you get an idea for what's going on there. And then we have all the water types related to that, ground source, solar energy, and then industrial process. So that chapter is particularly good if you're interested in looking at heat pumps and seeing what's going on. As far as a grid transition to renewables, that for buildings probably it's going to require utility scale. There are buildings that can do the individual, but it's still costly at a building owner level to do that unless they're financial incentives. Storage, seeing more and more electric batteries. I mentioned the utilities, but we've had compressed air systems, pump hydroelectric for a while. Flywheels and molten salt have all been available for many years. And then, we're replacing our fossil fuels with renewable hydrogen produced by electricity, renewable electricity. Other things, improving natural gas by adding hydrogen to it, biogases. This is EU. Unfortunately, this only goes to 2015. And I think from what I'm reading that fossil fuel portion for Europe has dropped probably another 10 to 20%. So it's down in the 20% range today. But hydroelectric, pretty constant. We've dammed pretty much there. Nuclear wasn't a lot added recently. Finland did add. But the renewables are now beginning to take a bigger and bigger bite of them. Also, this is globally, solar surpassed coal globally in 2024. There are other sources there, nuclear, wind, gas, hydro that are in that range, but solar is beginning to really accelerate. And this was from The Guardian back in January, and they so electricity or solar particularly is doing very well. But globally, this is from the U.S. Energy Information Administration. It's seen that coal's going to be kind of flat across the whole. Natural gas, maybe a little growth. Nuclear some, but it takes a long time to get a nuclear plant on. Hydroelectric, we've probably done everything we can, but solar is going to continue to explode in growth from where we are today to maybe 3 times that, along with wind. So they will be making up even more and more of the production today. And you see that by 2050, they're saying solar is going to have the highest production for electricity of any of the fuel types. And there's a little bit of competing differences between some of the sources here. A number of nations have said we're going to phase out coal, and to do that by 2040. That's what the dotted line shows there. But if you look at the line going across the center, there's China. China is still building coal plants. They need that just for have the electricity. The rest of the world kind of did okay. You see the little downturn, that was the COVID pandemic, but it's tipping back up. So if we're going to do this, coal-powered electricity production's got to drop by about 12% every year, which is a lot. And so I think until China is no longer building coal plants, are we going to be able to really have that happen and meeting that target? We've changed fuels many times. I mean, we did biomass, human and animal power, where everything was done. A little bit of hydro for a lot of that, but most of it was the human and animal. 1859, oil was discovered, producible oil in Pennsylvania, a long time before we started using it. 1930s, with the depression that happened there was a lot of work to provide electricity generally to a lot of places globally, and steam powered, coal powered power plants particularly, even though coal had been used in industrial processes before that. After World War II, gasoline vehicles, everybody wanted a car and being able to do that. And then by 1970, it was already accounting for 40% of energy consumption. But by 2020, fossil fuels were still are 78% of the global energy mix. But that means that there's another 22% that's in renewables or nuclear today. And so I think that's going to transition. We're going to see probably oil and coal taking a hit. EVs were doing quite well in the US, unfortunately, taking a bit of a downturn right now. I know some places, what was it, Norway, 55% of new vehicles are EVs in Norway. And the government's really pushing them there. And there are other places where it's approaching 20-30% of new vehicles. So we are seeing a transition away from that. So if we can get the coal down from the power plants and get oil down from using alternate vehicles, and it doesn't have to be just an electric vehicle. Seen hydrogen power recently being prototyped by several manufacturers. This is another roadmap from the International Energy Agency, and this is getting to zero effectively in 2050. And I just want to highlight a few things they say. I think they've got them in a little bit wrong order. This related to buildings. No new sales of fossil fuel boilers this year. This was written a couple of years ago. I don't think that's going to happen. We don't have good replacements for that, but I think it might be a 2035. All new buildings, zero carbon ready. That's 5 years. Zero carbon ready means that the building will be as efficient as it can, no fossil fuels. And once the grid becomes renewables, it'll be that building will be ready. Is what that means. Most appliances and cooling systems sold are best in class. I think that could be brought forward. We already have a lot of very efficient systems and appliances out there. 50% of existing buildings retrofitted to zero carbon ready levels. In the US, and I don't have numbers for other places, but in the US, we basically add about 3% of floor area to the building stock. That means that's the entire design profession, construction industry. To hit this level, 50% of existing buildings, 15 years, we're going to have to double the capacity to be able to do that. Yes, retrofitting doesn't take the intensity of building a new building, but it still means we don't have the people there. 50% of heating demand met by heat pumps. I think that could be pulled back by 2035 easily. Manufacturers are ramping up. And then 85% of buildings are zero carbon ready. That's still an aggressive goal, but I think that one may be possible as well by 2050. So last section I want to talk about is some of the resources that ASHRAE has put together for you. ASHRAE already has been the standards the standards authority for energy performance. ASHRAE standard 90.1 is now 50 years old this year, and it's so it is been looking at that efficiency for the building sector for many years, and that standard is aggressively moving toward carbon. Lots of new carbon metrics showing up in other standards. ASHRAE also does best practices guides, and that's part of what they're doing in this work here. Members in 130 countries. ASHRAE in 2022 published a position document on building decarbonization. These are essentially what ASHRAE believes in. This is done by a committee. They normally take 18 months to 2 years. This was done in about 6 months because it was actually easier to write than some of the others. And so ASHRAE believes in building decarbonization kind of as a focus, and you'll see that as in a lot of the work they're doing. I'm not going to read all this, but decarbonization can happen at any buildings. Let's see. Yeah, the last thing here is probably critically important. We can't forget the reason we have our buildings. We've got to maintain or improve our healthy and resilient indoor environments. They've got to be part of the discussion. It's not just energy efficiency and decarbonization. We have to have the buildings should become better at what they're doing to house people and give them good places to work and live. Challenges, we talked about a lot of this: cold climates, grid, return on investment, historic buildings. We're not going to probably put insulation on the outside of historic building. No mandatory voluntary code in a lot of countries. And so those are the challenges. Yeah. lots of things ASHRAE is committing. Basically, they're saying in our research, our standards, and our technical guidance, we're going to focus that resource on building decarbonization. That is the really key to that. And there are other aspects, I won't go here, but it's kind of all the things I've been talking about already. They also recommend that other groups, government agencies, non-government institutions, research standards and guideline development. Improve design and equipment applications for those groups, being able to the HVAC&R, the building services area, to be able to do that. Tools that support that, data and methods, that's kind of one of the key things to be able to do there. Workforce, training, getting people out in the industry that have the skills to be able to do building decarbonization beyond just the set we have now. We're going to need many more people working on this. Lots of standards that are related. I mentioned standard 34, refrigerant safety, the ASHRAE energy standards, existing buildings, 105, which deals with how do you go about determining how much or what the building performance is and the greenhouse gas emissions, reducing release of halogenated refrigerants, standard for high performance green buildings, relatively new standard method of evaluating net zero and net zero carbon performance. Several underway, and I don't have them all listed here, but there's one on passive building design, so think passive house as a standard. Evaluating greenhouse gas, this one was having a meeting yesterday for that. They've also been creating zero energy building guides. They've created 3, and I think that's probably all. K-12 schools, offices, and multifamily residential. So it covers a wide sector. And these guides show you how to get to zero energy in a variety of buildings, but also in most climates, which is kind of a key thing. If we can't get to zero there, essentially they're saying the building efficiency, you have to reduce typical building use by over half to get to the point where renewables can make up the difference. And so the other thing is the standards I've just been talking about, new construction, most of them talked about energy efficiency to begin with. Some of them beginning to talk about operational and embodied carbon, a few talk about renewables, not consistently even among the standards right now. Some of the whole life carbon and other, so the 105 for existing buildings talks about efficiency, carbon, and renewables, but not really about embodied or refrigerant. The refrigerant ones talk about emissions from there. 228 talks about operational refrigerant and renewables, but not about efficiency or embodied. 240 is supposed to be the one that combines that, but there's a new standard which is for calculation. And it's, to me, I'm kind of, these 3 standards, I don't know why they're not one. To me, they all deal with kind of the same aspect of what's going on. I think part of the problem was they were trying to get topics and things moving forward very quickly. 240, I think, probably will get published this year. It's very close. It's been under development for about 2 years. Lots of comments on it. So other resources, there's a Building Decarb 101 set of slides and other area. There's ASHRAE's resource technical and certification training. ASHRAE has coalesced all this in what they call the Center of Excellence for Building Decarbonization, which reports directly to the board of directors for that. And there's still a number of past presidents involved and other key people throughout. So their objective is just pretty much, let's get decarbonization, all the issues related to it throughout ASHRAE society. They delayed an update to the strategic plan because they wanted to get that decarbonization in there. Things they've already done, building performance standards, technical resource guide, grid and interactive buildings, decarbonizing hospitals, working with CIBSE, they published an update of CIBSE's TM65 for North America just last year, and then working with the DOE lab decarbonizing building thermal systems, particularly looking at heat pump and beyond. These are still not out there, even though it says winter 2024, that building decarbonization retrofit and the whole life carbon guide are still lagging. I hope to see them soon. They've been under development for a while. ASHRAE put money toward these, a lot of work, and it's technical committees. The standards is primarily volunteer, but ASHRAE has invested money in contractors to try to accelerate this work, working with an ASHRAE committee for that. So Decarb 101, it's a set of seminar material that chapters can present. There's the ALI courses. I've extended version of this talk, and fundamentals of design systems and equipment applications is second. So there's the kind of the next part for the buildings services side. So down to the conclusions. Buildings responsible for 37% of emissions, and that's going to grow if we're going to double the number of buildings in the next 40 years or so. Buildings, poorly designed buildings can lock in bad emissions for years. Decarbonization doesn't just mean changing out the fuel type, it means energy efficiency, cleaner energy sources, and then moving to electricity from low carbon sources. Now, operational energy dwarfs the embodied carbon in most buildings that we build, in most infrastructure. As those buildings become more efficient and their operational energy and carbon goes down, that embodied carbon is going to become increasingly important. And I think we're in a good spot to have the time to do that. I see a lot of good work in the area, particularly concrete and steel, to look at ways to do that. The Center of Excellence for Building Decarbonization is a way for ASHRAE to pull all that together. And if you go to the main ASHRAE.org webpage, you'll see, so that they have a research knowledge hub trying to pull all the bits and pieces. So there we are.
Thank you very much. For those online, if you want to, we can probably, we've got a bit of time. We're actually a little bit ahead of time, so that's good. So if you want to put your questions into the, I'm not sure, I'm ready here. If you want to put your questions into the chat, and I can read them out here. And actually, if you want, I think we can probably unmute ourselves. It may or may not work. If one person wants to try, we'll see if it works. If not, just type them into the chat, and then we can answer them. I'm getting terrible camera work here.
Yeah, I've been looking at the audience, but
Yes,
not at the audience. Sorry.
Yes, my old drama teacher will be very upset with me with that. I suppose a couple of questions that come to my mind while we're waiting. So on the life cycle analysis. Yeah, no, actually, yeah. You want to pull out? She said we should probably pull a couple of chairs around, and we can do that. I suppose on slide 94, I don't know if you remember that, I just wrote it down. No. we were looking at the different energy uses. Yeah. And we were talking about about coal sort of leveling out and solar increasing. Yeah. I'm just wondering, like certainly if you look at buildings and certainly houses built in the last 5 or 10 years, I think pretty much most of them will have solar panels, you know, they have some form of energy. Right. Do those figures include that? Or
some of those are a bit old.
Yeah, yeah.
So I think the last 2023, 2024, and even now we're seeing a big increase in that. So you might want to say 5% more, 10% more for the renewables. it's with the cost dropping so fast, it's kind of difficult to watch finding out what's going on. And there are definitely, I mean, it's huge. What did I see yesterday? The UK just said that all new buildings next year have to have solar. And that's gonna make a huge difference.
So, my question is really more about what gets measured gets managed. So I'm kind of wondering, I mean, I know people who have, I don't have solar panels in my house, I don't have an electric car yet.
Yeah.
Maybe soon, but I do know people who have solar panels on an electric car, and they'll show me the app on their phone.
Yeah.
And I'll go, oh, look, my car's parked outside the house right now, and I've got 3 kilowatts of energy being produced yesterday in the sunshine. I'm just wondering, like, if you think of all those houses, that's a lot of energy that's being generated by solar panels.
Right.
If they're not feeding that back into the grid, is that number being captured? Or maybe,
Yeah, that number is being captured,
Yeah.
and the electric utilities don't like the idea,
Mhm.
because if there's too much, like a day like yesterday, when there would have been great resource, could be too much.
Yes.
And the utilities need to catch up to the point where they have storage to be able to deal with that. I think I saw that the electrical outage in Spain was actually caused by a surge in renewable. That it overrode, the system didn't know how to account or accommodate that.
Okay.
And so that they're not doing it well. I know there was by law in the US, the utilities have to accept the power coming back. But it took a lawsuit because the electric utility for Hawaii, for example, where solar is just cost effective day one, was refusing new interconnects because it was destabilizing their grid.
Yes.
And they haven't quite dealt with that because they've been able to stabilize with nuclear and coal and natural gas. That natural gas you can ramp up and down pretty quickly. Nuclear, a little less so, but you can divert. And so they've been able to do that at a central level. You have all these distributed systems, it doesn't work very well.
Yes.
So, no, it doesn't account for that yet.
So we actually may be doing better.
We're doing better than
Yes.
these numbers, I'm pretty
That's,
sure.
yeah, that's kind of what,
Yeah, yeah,
that's
yeah.
what I was
Oh,
gonna say.
yeah.
Are we maybe underplaying our hand a little bit because
Yeah.
we actually physically can't capture all these.
I mean, when I
all
look,
these
when I look
micro-
at the things and they say by 2050, we have to have this done, I go, I don't see enough movement. I don't
Yeah.
see, I go through various places and I look at all the buildings in disrepair. How are we
Yes,
gonna
yeah.
bring them? But we've solved problems. So I think we'll be able
We've
to.
solved problems before, and I suppose as an engineer, I look at the numbers.
Yeah.
I look at, say, we're in 2025 now, we're at the
Yeah.
if you take 2000 as the,
Yeah.
we're now in the midpoint between the year 2000 and 2050.
Yeah.
We have good data for, certainly,
Yeah.
certainly in the 2000s, we have good data, so we can extrapolate between 2000 and 2025 and then 2025 to 2050.
Right.
And we've had boom and busts and lots of other things
It's
happening.
all gonna.
So I'd be interested to see those figures. I'm not gonna ask you to comment on that. That might be a little unfair.
I try. I mean,
Yeah, okay.
I'm always looking for data.
Yeah. Do you have anything online there? I can't say. I think we actually do have a question there. No, we don't. So one of the things we talked about is heat pumps. And we talked about heat pumps being the secret of heat pumps is when you get down to very cold level.
Yeah.
The COPs that we record in our sales data.
Mhm.
The COPs of 4, 5, 6, 7. When we get down below -1, -2, -3, we start going into
Or worse,
it starts going down from those.
electric furnace essentially.
Now, I think as somebody who used to sell heat pumps back in the 90s, which was a very depressing life. The point I would make is, okay, when you get down to -5, your COP is not the fantastic one that it is, but that's twice a year.
Yeah.
For a few hours, and the rest of the year we're at something better. So, you know, as long as we can still give you heat.
Yeah.
Having a poor COP for that amount of time, probably a bit of a, it's
I think for most locations,
Yeah.
but once we get above, you know, 55,
Yeah.
60 degrees.
Mhm.
Latitude that's where it begins to be a challenge.
Yeah, it is a challenge.
Yeah.
But if we can have a decarbonised electric grid, your COP
Then
is
it's
less important for me.
Yeah.
We're talking about decarbonisation of energy here. We are, and like you said, you made that point at the very start.
Yeah.
But I was wondering, is there any examples of, I mean, the answer to that is have water cooled, water source heat pumps as opposed to air source heat pumps. And is there any examples of an energy loop where you have buildings that are cooling, rejecting heat into an energy loop to be used by buildings with it where heat pumps are being used?
I have seen community scale loops where heat pumps are drawing heat or dumping heat into the loop.
Yes.
Particularly in Canada, where they know cold climate, so if the loop is running at 10 to 18 or so.
Yeah.
They're gonna be in much better shape than dealing with that outside air, so I think that scale is a more reasonable approach.
Yeah, I certainly saw it in, probably actually in the mid-90s in Oklahoma.
Yeah.
It's a Senate building, it's kind of
Yeah.
like a White House type building, which you're the, but it was, that was the campus, it was the big building where all the senators met, I think there were senators at least. And then we had all the offices around us.
Sure.
All on one big loop. I mean,
Right.
essentially what it was a water source heat pump, but just on a slightly bigger scale.
Right.
But there was no reason, but looking at it immediately, I kind of went, well, you know, they've got their data center, computer room, dumping the heat into it.
Mhm.
And they have, you know, the gym and the other bits that are kind of always needing, you know, always need cooling, dumping the heat into it, and then they have the big open space where. Yeah,
Well,
if you
and
put your
I've
oxygen
seen
there,
other-
you
I've seen
need-
other
you need a
things.
warm room, yeah.
The Dallas Fort Worth Airport, which was built in the 70s,
Mhm.
essentially has a 3 mile long
Yeah.
water loop
Mhm.
that they have central heat pumps and not central chillers to be able to add to that.
Yeah.
But it's I met with the facility engineer for that, and he said, I essentially have a 3 million gallon, sorry, I can't do liters in my brain on that. 6, 7, storage tank.
Mhm.
Because parts of the system aren't gonna need it and other parts are, and so we're just balancing temperature for the most part. And so there are examples, I mean, district heating systems in Scandinavia are quite popular. Seen some district cooling.
Yeah.
But not as much as Honolulu, Waikiki Beach was putting in, this was 10 years ago, a system that drew in 10-degree water from the ocean,
Mhm.
deep water,
Yeah.
and we're using that basically not having a chiller.
Yeah.
And so I think there are opportunities using water, lake source or large body of water is really very powerful.
You can take where we are now, as an example,
Yeah.
we've got an industrial park just built, what, 10 years ago, maybe a bit more. But you go, you know, approximately 2 kilometers in that direction. We've got Profile Park, we've got a whole heap of colo data centers, we've got Google data center, which is just over there. That's probably about 100 an egg in there.
Yeah.
The other things are 60 and an 80 meg, something like that. But there's 3 or 4 other data centers all within a kind of a 5 square mile area. And then you go in that direction, we've got about 5,000 houses, apartments and houses being built, all each individually with and that's a big, massive, you know, we have a lot of heat and a lot of heat that they want to get rid of, and a lot of heat that they want to be using, and a big talk on the internet and in the media as to whether we should even be building them. And then maybe there's 2 people who probably should talk there, you know. I think it's certainly working in that direction.
Yeah.
You know, anything else online yet? No.
I've not seen any more.
Feel free to type in any questions. Do we have any questions from the room?
Not a question, I guess, an observation. I was fascinated when you were showing the stat on the, carbon emissions related to buildings, 37%, I think you were showing. That's almost exactly the number in Europe that produced the Energy Performance of Buildings Directive in 2003. So that's the disconnect. You had this framework directive, then you had all the regulations, but the push was really on display certs, performance. Didn't actually change the behavior.
No.
So it hasn't actually, the number hasn't actually gone down globally. So that's the problem. When you bring in those rules to look at it, you gotta have a, so you just talked about a data center with excess heat across the road here. When the Guinness Brewery ran their own power plants, they had a district heating system down to the Ivy building. So, it's joined up thinking, but it's also making it happen as opposed to just having the regulation produce lots of effect.
But there's been a huge increase in buildings during that time as well. So at least we're not getting worse.
And in fairness, I mean, if you look at, say, I mean, it's what is not actually talked about. If you take a look at the oil usage, for example, in Ireland, so you can take this information from the NORA, NORA website will have it. And you look at, say, you can go back, you used to go back to about 2000, 2004, I looked at the other day, you can only go a bit from the day, but a while ago, you can only have 2007, I think was the last data that they had there. I'm not sure it's available if you spend a bit more time researching it. But I mean, just adding up the amount of meters cubed of oil, and there was probably I could be corrected. If anybody online wants to correct me, please do. You look around 2008, we were using about 9 billion meters cubed of oil across all oil, excluding air oil. That's for enterprise. That's calculated differently. So you're looking at motor diesel, motor petrol, heavy oil, kerosene, and green diesel for farming. So that's pretty much everything's fuel that's in there as well. But they're the big ones. We've gone from about 9 billion in 2007, 2008 down to about 19 billion down to 16 billion now. Dropped off obviously in 2001, 2002, 2001, 2002. It's been come back up again, which we would expect. So driving more again, but still, it's a significant difference between those two figures. But it's not. I mean, it's not anywhere near zero.
Yeah, I'd like to see the mass balance of what's gone up in the interim. So what has gas done in the same period? What's on-site generation that's excluded from that? Because those solar and numbers you're showing are probably more in the residential commercial building, but not on the industrial scale.
Well, I thought that normal one was an interesting one because that's an absolute. Like that takes into account the fact that that it's not per unit or per industry, right? That's just literally everybody else coming from the one tank. It's not from one tank, but you know what I mean. So we're taking less from the tank now than we were in 2000, and it's a this and then did that and then back up again. So but still doing.
I think the efficiency of our buildings, our building services equipment, lighting. I mean, the huge change that's happening with LEDs has dropped lighting in half in new buildings. So I think our buildings efficiency has improved substantially, even though we're building a lot more. So it's still 37%, but industry's better, transportation's better. So all in all, I think, yes, we're better, but we did not a lot better. So.
And then just talking about the life cycle analysis. So what we obviously every design of every building will follow the plan, do check, act. And I noticed on that slide you had, so that the hard bit, as you said, was finding
the DPPs.
Put the information down on paper.
And
then we had another step, and then the next step was okay, optioneering.
Right.
The difficulty I would say is that the question I would ask is, is that a too great a challenge at that point? In that,
Probably.
yeah, in that,
I covered that very quickly,
yeah.
but there are some early design tools that are intended to be,
Hmm.
they're gross level, but they give you, okay, your structure's the problem. Or, your interior is gonna be the issue, so you
Yeah.
can begin to look at those early.
Yes, yeah.
Yeah, by the time you're doing bill of materials,
Yes.
that ship has sailed.
And the reason why is, from doing life cycle analysis, the hardest thing I found
Yeah.
was, okay, I want to use a chiller. At this stage, I haven't decided it's going to be a ABC chiller. So
Right,
it's, type this, type that, type the other. I know I'm in around a megawatt cooling. That's probably,
Right.
and I'm going to do it with a chiller. And it's going to be air cooled. At that point, I want to make a decision.
Right.
Is that the right way to go? Or sorry, advise the client on the decision that they want to make, to say, yeah, look, I'm saying it's going to be an air cooled chiller, but would you consider a water cooled chiller with a cooling tower? So your COP is going to go up, but your water
I
use is going
don't
to
think we have enough data right now
Yeah.
to make that kind of judgment.
Yeah.
That's. I think as the demand for the EPDs and DPPs is there, that's when.
Yeah.
we'll do it. We're beginning to see the EPDs come out in Asia.
Mhm.
And as that equipment gets distributed, we'll see more. North America, Europe.
Yeah.
But, there just doesn't seem to be any will that. Not to speak poorly of the manufacturing community, but they don't like change particularly.
I do find, and I suppose I would equate this to, I mean, you're in the modeling world, and back when modeling, like the Reddits and the world were coming in with products, and we were taught, and the manufacturers of the world, and you still see it actually even to
Oh,
this
yeah,
day.
no, even today,
Where you'll say, can you give me the family or the model or the
No.
STP file?
yes, the answer is no.
Well, the answer is, the answer is maybe now, I think is probably fair. But if you go back to the mid-2000s, the answer was, under no circumstances, I'm not giving that to you. Write me a check and I'll give it to you.
I was working on a corporate headquarters, about 45,000 square meters, so a big project.
Yeah.
And in the contract specs was for any piece of equipment, any large chiller that you want to propose, you must provide performance map.
Yeah.
And we did simulations of 3 different manufacturers.
Yeah,
Because we had, but they were more willing when it was that piece of equipment that's
Yes.
of this size with these. They didn't want to give us a map for the whole family. And I don't, there is a new standard recently published, 205, which specifies the format of the map and how to propose it, specifically for modeling.
Yeah.
The manufacturers, I mean, Carrier and York and Train were all in on the meetings, and they drug their feet. They
Yes.
didn't want to participate, and that's still true.
And like, I've worked for vendors as well,
Yeah.
so I can actually understand where they're coming
Oh, yeah.
from.
It's,
Like you could,
they're proprietary, but if I can't compare your chiller to their chiller, how do I know, what the advantage is?
Yeah.
It's the same sort of thing I'm seeing right now with, BRF, BRD, is they're not good performance maps.
Mhm.
On the cooling side, they're decent on the heating, but even the manufacturers, I talked to one 25 years ago and said, this, they wanted to get it in the Energy Plus model I was working on, and said, fine, but we need maps, at least the fault map, and they couldn't.
Yeah.
So if you can't do that, I can't compare you to an air source chiller or a heat source.
so how do we get good enough? And I see what I'm saying, how do we get good enough information from them?
Yeah.
That they're not putting them under an undue financial issue or resource issue, or indeed showing their wares to the market, to their competition. Because it would be unfair to ask them to do either of those things. But how do we get enough information to be able to make a decision? Because the decision that we make now, because we're talking, you had lots of graphs there where you're putting things out to 2050. The decisions we make at a desk affect what's going to happen
Those
in
buildings
2050.
that are already there, California's utilities came together in the 1990s, and they were bemoaning this problem that they had no good performance curves for any of the cooling products primarily. And what they did was under NDA, collect the information from each of the manufacturers, and then they created a composite based on size and, types. And then that was published. So that didn't reveal any information of the manufacturers.
Yes.
Unfortunately, it's 25 years old now. But it was the best attempt I've seen of really moving that, trying to get it away from knowing I can't reveal that I'm better in this one piece.
Yes, yeah.
But that's the only way I've seen it, is protective privacy in that respect, but they don't want to share the information.
I think, well, I'm not entirely, in fairness, I'm not entirely convinced that it's that they don't want to. I just don't think there's anything in it for them just yet.
Well, that's
So, I mean, if I was a manufacturer, what I would want to be hearing is, if you do this, I can say that it's for you, which I think is it's
Yeah,
that's not
And
something that anybody can ever actually say.
no,
Yeah.
that's a real challenge.
Yeah. So,
I mean, that's essentially what we told them when we were doing the big chillers for the corporate headquarters. Is there one more?
No, it's just me.
Okay.
If anybody's online and wants to weigh in on the discussion, feel free. Yeah, we have a few minutes.
In the end, there was less than $1,000 difference in operating energy between the three of them.
Yes. Yeah.
So it did not change the numbers. We thought it would, but it did not. So it's, and I can't, for that reason, there's probably not enough to give them, oh, well, if you give us the data and you're the most efficient,
Yes.
then you get the job. But
The other way we could do it, and of course the immediate downside of that
Yes.
is what you do is you say, okay, if you give us this information, or you can't be on the list unless you give us this information.
that's the other way.
But
Yeah.
the problem with that is then that will immediately exclude smaller manufacturers and really push towards, it will make it will be unfair.
Becoming more of a monopoly, which is
Yes,
not good.
which is the opposite direction.
Well, and I know when the ASHRAE 90.1 committee is updating the efficiency levels for the various equipment, they are looking at the market and seeing, I'm not trying to exclude people, but the lowest 20–40%
Yes.
efficiency levels are being forced to either improve or you're out of the market.
Again, probably one of the most salient challenges that we have, and you touched on it earlier on in the earlier slides, is that every building that gets designed
Is a one-off.
is a one-off. Everyone is a prototype, and it's very, very hard to legislate for that.
Yeah.
And if anybody wants to weigh in on that,
I can ask a question.
please, sorry.
Why there is such a big focus on heat pump? And I understand why. I mean, they are efficient, right? But you electrify the heating, but on the other hand, the biomass is kind of out of the game. I mean, the whatever is growing, like we are not using to for example, you have a new house estate, you build a district heating system for like 100 houses or
Right.
maybe less, and just have a big boiler, oil efficient, and then heat those houses, and then you only have a blackout. You're not worried, well, I'm gonna be freezing in the winter.
Right.
I do see a lot of push, and I was kind of working for a little while, almost 2 years on Mitsubishi. I was working as a technical designer. Well, I was kind of technical advisor, size the heat pumps for people, and that's what I was doing. But look, I know in Ireland now, like the focus is just like electrify the heating,
Yeah.
go towards the heat pumps. I recently bought a new house, has a heat pump, and I'm glad with that, like don't have the hassle of lighting up the fire or just but like why people are avoiding this type of fuel, like the biomass and the sort of heating
Partly
system.
because its carbon equivalent is very high.
It's carbon neutral, right? So
Some people would claim that, yes. At the Department of Energy in the US, a heat pump is a renewable resource, which I disagree with, but. I, well. We have a small cabin about 50 miles west of Washington in the mountains, and we have electric heat pumps. But we also have a fireplace. And we have plenty of resource for that. But, and even in our own home, we had to replace our central system. And we had a choice of going all electric, getting rid of the gas. And my wife said, nope,
I don't know, we don't work,
electricity does go out. So,
I don't know, we don't work on sites and, what I see, the schemes are full of waste timber.
Yeah.
And I'm just wondering where the timber goes. I'll be glad if I do that timber go with the power plants, and produce electricity for Ireland, but I don't think it does. Might, I don't know, but like, I know like there were guys, collecting timber in their vans, and they brought it home for their wood burners, to heat the house, and they have pretty heating during the winter because no one dies of that wood from the sleep,
Yeah.
So, yeah.
yeah. The carbon neutrality is a debate that's being had in a lot of ways. Yeah, sequestering is good, but are you actually doing the sequestering on the site is a kind of a challenge. Otherwise, you're beginning to transport and get all the other elements related. And is it actually being sequestered at the rate you're using? Is it?
I think that to maybe summarize that, hopefully you're able to hear the both sides of that conversation at home, online. I think that you touched on a really good point. Like everybody's talking about heat pumps, and in the motor industry, everybody's talking about EVs.
Yeah.
And well, maybe a little bit like myself, you've seen a couple of winters, and you've seen a few of these debates.
Yeah.
Where it's, like in the mid-2000s, there was a huge move towards bio fuels, and just before that, there was a huge move towards combined heat and power, being the only show in town, and then it was biofuels. Then went back to a couple of years later, and then we moved back to heat pumps again. Heat pumps were in the wilderness for a little while, and I think the truth of the matter is there is no silver bullet.
No.
And what we're talking about, and the very fact that you've had 139 slides here,
Yeah.
we need to remind everybody that this is not a straightforward subject. That it is a complex subject, and anybody who says that there is a silver bullet, there is a single answer.
That's a beautiful
yeah.
thing. Heat pumps are a part of the solution,
Hmm.
but there are lots of other things going on. And people are still proposing using green hydrogen in houses. And I can just see the Hindenburg blowing up in a house, essentially. Not a good thing. I don't think that we have the safety levels in our houses to be able to do that today. But there's a lot going on, and this whole debate is driving manufacturers to think of new ideas.
Other thing is there, right? So we're trying to implement as much renewable energy as we can, be more, it's just have a green generation of electricity. But again, we haven't come with a clear solution of how do we store that electricity and how we manage the peak demands and the peak power production. Like like nighttime, the wind might blow very,
Right.
very, very high here in Ireland, but then in the morning when you have demands, it stops blowing, where
It comes down to lots of different ways of doing storage.
There are, yeah, but like.
And if you have a distributed system for a community with heat pumps, then you have a place to store heat or store energy of some
Yeah.
sort. And that, I think it becomes really the opportunity, and not many utilities are really embracing that yet, not enough. So.
Thank you.
We want to, one more thing toward the end, just to let you know that there's URLs for all of this. So if you want more information,
It's there.
it's there. That's why you said 139 slides, because I think the last 15 are
But the point being that that's just the tip of the iceberg.
Yeah.
Yes.
And I left my email address. I'm happy to chat with anybody if they want to talk about it.
So I'm gonna be here in a few minutes. We just throw up the closing slides there. And thank you. I just want to say thank you everybody for joining us online and here in the room. There are plenty of resources. We'll try and get these slides onto our website. It'll be in our members section as soon as we can, and we'll get we're recording this, so we'll put this up onto our YouTube. It'll take a little bit longer, but we'll get it up there. But if you go to our website, there's plenty of resources there. I mean, just getting through your list of links, so will be some good midnight reading, but there's plenty more up there. So I just want to thank Drew, particularly for coming all the way from Washington DC via London, via Athens. So you'll be happy to get back to stateside. And just jump on to the next slide there. Oh, actually, I can do it myself. Thank you. I want to thank Dr. John for hosting us here, and Ermid for had a lovely walk just beforehand around the fantastic facility here. I want to thank all of our sponsors who make these events possible, and I look forward to seeing you at our AGM